Alright, the rational root theorem today, ladies and gentlemen, is just talking about any kind of polynomial that we have, and what you're going to do is you're going to look at the first and last terms. Okay, so p of x plus whatever t of x is. Okay, so whatever those terms are, you're going to be looking at them. Okay, because the rational root theorem says that a 0 exists at one of these possible situations. Okay, so we're going to have the factors of t of x, okay, divided by the factors of p of x. Okay. Alright, so let's say we had something as simple as this. Find all possible rational x-intercepts of x to the fourth plus 2x cubed plus 7x squared minus 8x plus 12. Okay, so define now this is for when the Tartaglias of about 400 to 500 to 600 years ago were in Italy trying to find these type of problems and trying to solve these complicated above a degree of 2 type of problems. And so they actually had to work it out by hand all the time, whereas today we would graph this, see where it crosses the x-axis, and start from there with our synthetic division. Okay, so basically we would just do the factors of 12, which are alt 241 plus or minus 12. We got alt 241 plus or minus 6, comma, alt 241 plus or minus 4, comma, plus or minus 3, comma, plus or minus 2, comma, plus or minus 1. Okay, and that would be all of the possible numerator possibilities I would have on top. Okay, and then on the bottom I would obviously have just plus or minus 1. Okay, would be the possibility. So that means that I would try out, I would just start dividing down the middle. So I'd have plus or minus 12. Well, it just basically mean if you can see where this is going. Okay, I'm going to be using the same numbers as I have up here. And so what I would do is I'd check synthetic division with all of those with this polynomial to see how to solve it. And one of them is guaranteed to be there. Now also a part of the rational root theorem, and this is an interesting one, is I know this is a degree of 4. So that means I know that I have 4 or 2 or 0 real roots. Okay? So that's a huge important part of knowing the degree. You always start at the degree and then you subtract 2 till you get down to 1 or 0. Okay, if this was an odd, I would be like, if it was 5, I would be saying, okay, it has 5 or 3 or 1 real root. Okay. All right, now if whatever conversely it has, okay, you have to think about this. All right, this means it has 0 real roots or 0 imaginary roots if I have 4 real roots. Okay. This one, it would have 2 imaginary, and this one, it would have 4 imaginary, depending on which combination I got. So if I got done testing all of these, I would know that I would have imaginary roots, and I'd have to go do some constructive things with the imaginary. But the stuff you guys are dealing with, you'll be given at least 1. To start with and stuff. Now this is if you had to do it by hand. I would strongly recommend go to your calculator. Let me see, what is it? X to the fourth plus 2x to the third minus 7x squared. Okay, as you can see, we're getting some pretty funky stuff going here. Minus 8x plus 12. Okay, so we have some stuff right here. So as you can see, all of those numbers show up in my combination, so those ones are the ones I would use. As a matter of fact, since this is all 4 and since I graphed it, I would just move on and just say, oh, my answers are 1, 2, -3, and -2, and just move on from there. Okay, now let's say we went back to something like this. Okay, now on this one, I would say 1 and 0 are possibles. Okay, now remember, this isn't this right here is not all possible combinations. It's just a starting point. Okay, so I would have to test this off, and plus I would probably be testing all the factors of 8, to be honest. Okay, all right. Now, if I had for some reason the graph, there we go. Well, this one gets a little bit higher. Let's try to go. I want to get you guys something that looks a little bit more interesting. Let's go 6. Nope. 5. No, that just decreases that part. So let's go 7 again. Well, that's just not working it. Okay, anyways, I was trying to get it to be where it just touched the very tip of the maximum at the x-axis, and that would mean you have a multiplicity of 2. So you would have 2 possible answers of that. So you have to be very careful. So like, for example, let me show you what that would look like. Okay, let's say I had a graph that was like this. Let's pick a different color. Yeah, there we go, red. It touched here once and then came back down and then came through again. Okay, so here is one answer. So this is one real root. Okay, and right here is actually 2 real roots. Okay, so that's a possibility of 3 real roots. Okay, so when taking a look at that, you have to understand is that on this one, whatever number it is, you say it twice. So let's say that this one on the right was 3, so that's 3, and then this one on the left was -2. It would be saying -2, comma, -2 would be my answer. Obviously, we would just say, what we would say is 3, comma, -2 with a multiplicity of 2. Okay, so the 2 would actually have the multiplicity of 2. So you have to just be very careful on how you're working that. Now, what you could also do is use René Descartes' rule of sign change to actually tell how many positive and negative real roots you're going to have. Okay, so if I go from front to back and I just kind of count how many times I change the signs, I can tell you how many positive roots I'm going to have. So on this one, I didn't change signs, so that's a 0. This one I didn't change, that's a 0. This one I did, that's a 1. I didn't change, so I'm still at 1, and then 2. So I have at least 2 positive roots, and which actually did match to what I was just saying. Okay. All right. Now, if I wanted to find the odd, or I'm sorry, if I wanted to find the negatives, what I would do is I would take this function f of x, and I would plug in a negative x and then count the sign change. So I would have, this would still be x to the 4th because when you square it, it becomes that. This would become minus 2x to the 3rd. This would still be negative 7x squared. And this would turn into positive 8x, and this would still be 12. Okay, and so René Descartes, I'm going from positive to negative, so that's 1. Negative to negative, that's still, 1. Negative to positive, that's 2. Okay, from positive to positive, that's still a total of 2. So I have 2 negative real roots and 2 positive real roots, which actually matches the information is what I got. So you can actually discern some pretty cool stuff from just looking at this, and by using the rational root theorem and René Descartes' rule of sign change, and I don't remember what that other one's called where you have this, so that's just something just to work with. Okay, All right. Thank you guys very much. Have a great day. Bye.